Hi and welcome to Simultaneous Equations video 4. In this video we're going to talk about the algebraic approach called elimination method to help us solve sets of simultaneous equations. You will develop an understanding of how to solve these pairs of simultaneous equations through examples that I'll take you through. We'll look at a range of simple to mostly complex examples. Let's have a look at example 1. In this example I have x plus 3y is equal to 13 and x minus 4y is equal to 2. And this is a fairly simple example of the elimination method. Now, the key feature of the elimination method is all about getting my x's or my y's to match and then doing an operation on the equations in such a way that I'll eliminate one of my variables. So let me show you what this means in this simple example. Let's imagine if I said equation 1 minus equation number 2. Now let's have a look at how this looks. First of all, I have my x values here. X minus x would be equal to 0x. And secondly, I have my y values here. And I have positive 3y minus negative 4y. So plus 3y minus negative 4y. And this is equal to, and then I have my numerical values. 13 minus negative 1. 13 minus negative 1. And that will, of course, give me 7y equals 14. So when I subtract a negative, it's like adding. And notice what I've done there. I've created now an equation, this one here, which is just in y. And I've done it by doing an operation on my two original functions. I've subtracted function 2 from function 1, and this has eliminated my x value. So I've got no x's left. I've made sure I had the same number of x's in both functions and then done that subtraction to remove the x's. So now I can solve. I divide through by 7 and that gives me y is equal to 2. And then I can use this y is equal to 2 in either function. So I'm going to say sub y equals 2 into number 1. And that will give me x plus 3 times 2 is equal to 13, which means that x plus 6 is equal to 13, and x is equal to 7. So I have x equals 7 and y equals 2 as my solutions, and I verify. Notice here that I verified, or I used number 1, so now I'm going to verify in number 2. Number 2 is x minus 4y, which is 7 minus 4 times 2, and that's 7 minus 8, which equals negative 1, and that's what I was hoping it would equal to. Let's have a look at equation or example number 2. In example number 2, I've deliberately chosen to use a and b. I really want to show you that you can use a and b or any other variables we'd like to. 3a plus 5b is equal to negative 1, and 2a minus 5b is equal to negative 9. I've set this up deliberately because, again, we already have a matching set of coefficients, the 5b's, but this time I have 5b as a positive in the first equation and a negative in the second equation. So let's call this equation 1, and this one equation 2, and I'm going to do 1 plus 2. And that will eliminate my b's because 5b plus negative 5b will eliminate the b's. If the signs are opposite, I'll add the equations instead of subtracting. So now I get 3a plus 2a is 5a plus 0b is equal to negative 10. This, of course, means 5a equals negative 10. I divide by 5, and that gives me a is equal to negative 2. I sub a equals negative 2 into, again, I'm just going to use number 1, and that will give me 3 times negative 2 plus 5b is equal to negative 1. Negative 6 plus 5b is equal to negative 1. I add 6 to both sides. 5b is equal to 5. I divide by 5, and b is equal to 1. So I now have a value for a and a value for b. A equals negative 2 and b equals 1. I do my verification. Notice here that I used equation 1 earlier, so I'm going to verify in 2. And equation number 2 is 2 times a, which is negative 2, minus 5 times 1, and that's equal to negative 4 minus 5, which is equal to negative 9, which is what I was hoping it would be equal to. So there's example number 2. And finally, let's finish with example number 3. So moving down, here's my example number 3, and this time you'll see that I have very deliberately got coefficients that are all completely different to each other. So now we need to talk about how we could match these equations up. This is a bit of a step up. So it'd be worth reading some examples from maybe your textbook or other resources. There are in-between questions here. But I'm going to jump into this question, see how we go, and hopefully you can use the principles I apply. So what I'm going to choose is I'm going to match my G coefficients. So match G coefficients. And I'm going to do this by calling this equation number 1 and this equation number 2. I'm going to do equation number 1 times 2 and equation number 2 times 7. So I can multiply everything in an equation as long as I do everything. It's going to blow my numbers out a little bit and make them quite large, but what it will do is it will create 14g in both cases. So first I'm going to multiply equation 1 by 2, and that will give me 14g plus 8h equals 92. And I'm going to call this equation number 3. It's still a derivative of equation number 1, but it is a little bit different, and I may want to call it specifically over equation number 1. So I'm going to call it equation number 3. Now what this has achieved for me is I've now got a 14g. And by multiplying equation number 2 by 7, I'll also get a 14g. And I'll get some other stuff, which is not so important, but I will need it later on. I get 35h, and that's equal to 49. I'll call this equation number 4. But now I'm simply going to do equation 3 minus equation number 4. I'll do a subtraction there. And that will eliminate my g's. So 0g, and then I get 8h minus negative 35h gives me 43h. And 92 minus 49 also gives me 43. And now I just simply divide by 43, knowing this is obviously 0. And that leaves me with h equals 1. And then I'm going to substitute h equals 1 into one of my simple equations here. So I might just do it in number 2 this time because g has a smaller coefficient. So it seems like an easier way to go. So I have 2g minus 5 times 1 is equal to 7, which gives me 2g is equal to 12 when I add 5 to both sides, and g is equal to 6. So I have this. H equals 1, g equals 6, and now of course I verify. And in verifying my solution, I have to use equation number 1 because I've already used equation number 2 here. Equation number 1, the original one, is 7g plus 4h equals 46. So let's have a look. 7 times 6 plus 4 times 1, and that's equal to 42 plus 4, which is equal to 46. And my verification has shown that this is true because I was hoping to get 46. So just remember that as you go through, you should always verify. And by verifying, it will almost certainly tell you if you've done something wrong. You'd be pretty unlucky if you'd made a series of mistakes that led you to a correct verification. And then you can go back and find your incorrect or your mistake that you've made. So that's the end of video 4. All the best.